Greetings and welcome again to everyone. My name is Kate and I work at CIMMYT, and I'd like to thank all of you very much for joining us for today's session of the Excellence in Breeding webinar series. We will be hearing about a new tool to facilitate visual selection that was worked on during an EIB Module 5 sabbatical. Information about this tool was available during the EIB meeting 2 weeks ago, but today we can learn about it in more depth. Before we begin, I would like to let everyone know that we will be recording this seminar and we will make it available later for anyone who may want to access it. During the presentation, if you have any questions, please feel free to share them through the chat window, or you will also have an opportunity to ask them directly to the speakers at the end of the talk. So before we begin, I'd like to introduce two people whom we will hear from today. First, I would like to introduce the person who hosted the EIB sabbatical, Dr. Juan Bergueño. He is the current head of the Biometrics and Statistics Unit at CIMMYT. Juan began his studies at the Universidad de la República Uruguay and then completed his master's and doctoral studies at the Colegio de Postgraduados in Mexico. Juan has served as a professor at both of those institutions where he studied, and he also worked at the Mexican Social Security Institute. He joined CIMMYT in 1999 and took his current role as the leader of the BSU in 2014. Juan will give the background context of this project before turning over the presentation to Dr. Ibnu Dieng, who will describe ViTSel to us and give us a demonstration. Ibnu is currently the head of biometrics at IITA. He began his studies in statistics at the National School of Applied Economics in Senegal, and then went on to get his master's and PhD in biostatistics at the University of Montpellier in France. He then worked as a statistician for over 3 years at CILSS, the Permanent Interstate Committee for Drought Control in the Sahel. And he next moved into the CGIAR, where he began his work at Africa Rice in 2010, where he became the head of data integration and the biometrics unit. In January of 2020, he moved to IITA and continues his work there today. So I thank Juan and Ibnu for joining us today and welcome them to start their presentation. Juan?
Yes. Good morning, good afternoon, good evening, everyone. Thank you for participating in this webinar. I will just do a brief introduction about the context of this development. As most of you already know, that in BSU we used to develop some software for breeders, and this is in the context of this. We already had one software for line-by-tester visualization, but under the sabbatical program of the Excellence in Breeding platform, we decided to continue developing a visualization tool for other kind of analysis, especially for multi-environmental analysis. I met Ibnu some time ago in Africa in some Excellence in Breeding meeting, and then we decided to work together under this sabbatical program that I guess, I don't have a complete evaluation of it, but I guess it was a very good program in order to share information between centers, to create or to start new collaboration between biometricians in the different centers. The idea of this kind of tool is based on provide breeders with statistical and computing tools to run several kinds of analysis. Usually we try to develop some easy to use software, and you have to have this in mind because probably you will find many things that are not in need or things that you cannot do with the tool, but the idea is to do more routinely analysis that the breeders need. The other idea of this kind of software is to use kind of modular, create modular components in order that all of them can be used by the breeders in their own computer without the need of internet connectivity. Sometimes this is a problem, especially for national program and for some regional office of the CGR. And of course, because we have kind of modules, all of them can be used in a more large system like EBS or BMS. And this is part of the idea also to develop this. We can produce a few pieces, and all those pieces can be integrated in a large GR, like the EBS system. With this, we try to contribute to the breeders to do better job, to use most and best statistical methods, and then at the end they will have a better genetic gain. That is our expectation. The successful of our software is clear if you see the number of downloads that we had. Approximately 5,000 people have been downloaded the software in the last 5 years. With this, I will let the word to Ibnu to start with the presentation in which you will be, or you are more interested, I guess. Thank you.
Thank you, Juan. Thank you, Kate. Good morning, good evening, good night, everybody. My name is Ibnu Jeng from ITA, and together with colleague from CIMIT, Francisco Rodriguez, Angela Pacheco, Gregorio Alvarado, and Juan Bugueño, the head of PSU at CIMIT, we are presenting ViTSel. What is ViTSel? ViTSel stands for Visualization Tool for Selection. It is a new user-friendly tool to his selection using results of multi-environment and multi-trait analysis. And as just Juan stated, we met, I think it was in 2007 in Nairobi during one EIB meeting. At that time, it was the head of the data integration of and biometrics unit at Africa Rise. And Juan was the head of the biometrics and statistical unit of CIMIT. And then we were just discussing in one of the breakout session led by Module 5, and we was just discussing how we can expand collaboration across our centers to develop and to address issues that are common to our centers. And we was just brainstorming, and then after this sabbatical initiative from the EIB Module 5 came on board, so we were saying, so this is an excellent opportunity to continue working on that direction. So then we proposed in consultation with Juan, as I mentioned, CIMIT BSO head, a proposal to EIB so we can jointly develop tools for breeders to his selection. So luckily that proposal was funded, and I visited CIMIT in late 2018 when we brainstormed, and then it was very innovative, this program, in the sense that it allowed for a short-term 1 month where we can concentrate effort and work with the CIMIT biometrician. We concentrate also critical mass and on a particular topic to address similar concern of a decision support tool to develop for CDR centers and beyond. So then we propose ViTSel, as I mentioned, visualization tool for selection. So why ViTSel? We know that there are already various tools to run statistical analysis on raw data after breeders accomplish the evaluation of performances offline, usually in a single or group of environments. Output of these analysis are usually what we know already: the descriptive statistics, the mean of the genotypes, the BLUPS or BLUES, heritabilities, and so on. But one question is how to consider and combine all these outputs in a single interface to allow breeders, after running analytics, to quickly and easily make a decision. So that was the question we intended to answer by developing ViTSel, a new interactive application. ViTSel needs some input data. Just as an example, we will we assume that statistical analysis using mixed model have been already carried out, and then the G by E table with BLUPS and BLUES is available. So We have the data by environment, stacked by environment, where we have a G by E analysis, and we get the performance of the lines. Here we have the environment 1, the environment 2, and also on. If you have also the combined analysis, we can also include it in this G by E table. So this is the input data that all ViTSel need to run some visualization and then assist in the selection. So just quickly, we have two components. We have a visualization component where we have the classical box plot to see the variability inside and then compare environments to see the variability. We have the heat map, which one were, to quickly assess what are the best genotypes across environment or in a particular environment. We're talking here about local adaptation or mega varieties. We have also the bioplot, classical bioplot of the genotype by environment, and then the scatter plot relationship between traits for environment. The second component is the line selection assist, where we can compare the new genotype that we want to test to locally adapted varieties. Here we're talking about the checks to see whether our new genotypes are beating the checks or not. We can also compare the new genotype to specified values. We can, for instance, consider the performance of the TPE. We can see that the average of the TPE can be seen as a potential of the TPE, and see that and select all the genotypes that are above the average of the TPE. Two methods of index selection also are available: the rank summation index and the base index. We want the tool to be easy for use, so we invest on quick visual assessment, where we can use multi-trait analysis and consider the trait where higher, lower, or between values range are combined in a single interface, and quickly and using a quick visual assessment, we can test and then select the genotype we want. And then, of course, last but not least, we can select based on single or group of environment based on the objective. So in addition to the performance and then the selection, comparing the genotypes to the locally adapted varieties or the standard values, we could also, considering the shoe class stability, can help also to look at the stability of the genotype across the environment. So I'm going to demoing the ViTSel, and here in this last slide, I just want to show the partners that were involved in this project. As I mentioned, when we started this project, so I was Africa staff. I shifted from Africa to IITA this year, and then of course CIMIT was there, as I mentioned, as a host center, and then we developed and collaborated together to develop this tool. Of course, all this under the support of the excellence in breeding that helped for this sabbatical program. So what is ViTSel? ViTSel is a web-based application that is developed using R-Shiny. Is installed locally, as we've seen here. We install it, is portable. It comes to the machine like in a container, like a Docker, and everything is isolated in a container, and we bring an R portable, the version 4, with all the necessary libraries and all the CSS file and all the needed the codes and whatever the data, all the necessary, all the requirements are in a container, and this container is the installer that is installed in our local machine. That is not going to conflict with the R we might have that is running, because developing ViTSel was fine, but distributing can be challenging, because we can all have R that is running with different version and different libraries, version of libraries. So then what the option we choose was to like silos where we can have all the necessary R new version that is different to the version one may have in our machine, and all the related libraries with their version isolated in a container, so that we can run ViTSel without any risk that it will alter the R we might have in our local machine. And if you upgrade the R we have in our local machine and update the libraries, it won't affect also ViTSel and vice versa. So when we install it in our machine, at this time we have a Windows version, but we may work in the future to have a Mac version and so on. So we launch it, we will have this interface that will launch using the default web browser. So mine is Chrome, so it just launched in Chrome, and then we have here simple interface. We have the menu. So here in the about, so we remind the partners, and then all the third parties application free we use, and how to cite ViTSel. So we need an input file, as I mentioned, and then shown previously. We can download this example to see how the data should be organized. So then I have a data that is already organized in that way. So I will just browse in my local computer and then select this one, the example file, open it. So there is some dialog box where I need to select. At this time we have the XLSX file. Yeah, but in the future we'll be having the possibility to upload either XLSX file or CSV file, whatever that is in the need. So then, as it is an XLSX file, we need to select the sheet where the data are stored. And after that, we need to tell to ViTSel what in that data, what is considered as genotypes, for instance, here the variety, what is considered as environment, is the site, and the trait we want to visualize. So then here I have three traits: the flowering, days to flowering, the plant height, and then the yield. I can view the data that render here in this page where we have the raw data all, as I mentioned. So we have the data by environment, stacked by environment, and have the varieties, and then the two traits, and we have all the environment here. So in the summary, we have just like a summary of what we render in the previous page. Here we have the, for instance, the first trait, days to flowering, where we have an average by location, and then the overall is the combined analysis that come from the mixed model. So here we have some descriptive statistic, the mean, the standard deviation, the median, and the max, just to see that everything is working fine. So this first page is just to import the data to ViTSel. So now these two menu will help to visualize and then to select. So for the let's start with the visualization. So we have four visualization: the biplot, as I mentioned, the box plot, the heat map, and then the scatter. So for the biplot is the classical biplot we have, and as the system is interactive, based on the traits we input. If you remember, in the input file, we were selecting the traits that are in our Excel file. So we have chosen 3 traits. So we can select here any trait we want that we input it. So can plant height, the yield, and then from that we just have the classical biplot where we have the first dimension and then the second dimension, where we have the genotype in blue, and then we have the environment in red. So here also we can select the dimension as we wish, and if you select dimension 2, it will immediately go to dimension 3, 4, or 5. So the number of dimension is related to number of we restrict it at this time to 5. So to see that, okay, between 1 and 5 we could see all of the variability that is containing in the GBA table. So after the biplot, we have the box plot, just a classical box plot where we have the variability inside environment. Here the environment 1, and then the environment 7, and you can see that which environment are most variable compared to other one. Here also is interactive. You can select the trait you want, and it will render the box plot based on what we have chosen here. So we have also the heat map. This is the which one were principle, where we have this this scale. Darker the color, higher is the value. So that will depend now on, and then we'll come on this later, that will depend on what we wish. If you want to have higher values, we can see that we are interested to see darker color. For instance, for the yield, we can think that higher is the yield, better it is for genotype. So we can quickly see that the genotype we have here, and then the environment, For instance, this genotype is better in this environment 10 compared to the other environment. This genotype number 10 is good in almost 1, 2, 3, 4 environment. And if you go, I think there is one genotype here, the 37, that is almost good everywhere. So this is also interesting to pick quickly and then see that, okay, this I can shoot this genotype as a good candidate, and I can go further to investigate in the next couple of screens. So here also, as the same is interactive, you can select the trait you want and then and see how the genotype are doing based on that trait. We have also the last visualization tool we have is the scatter plot, where you have an ensemble of plot or statistics. For instance, here we have a matrix where we have the flowering here. We have the density plot for the flowering and based on the different environment we have. So we can see in the average mean for each environment, and we see that here this last one is the most high yielding. Days to flowering having higher days to flowering compared to the others. So here we have the plant height, the density for each environment. Here we have the yield. So this is the high yielding environment that can match also the box plot we have seen. So here we have the scatter plot where we compare to the plant height and the days to flowering. We can see some trend decreasing. We have here as I mentioned, the days to flowering here, and then the plant height. And also we have identified by environment. And here we have the correlation between, it's the same information we have roughly, but here we have the scatter plot, and here we have the correlation for the flowering and plant height. After the visualization, so we can go for the line selection assist, where we have different modules. So the first, as I mentioned, we want to investigate and compare the new genotype we are testing to locally adapted varieties, mainly the Czech. So we can do this using the combined data. We can do this in one location, for instance. Let's start with the combined data, where we have the combined analysis that come from the mixed model. We can select my check of interest. I can select one check or two or more, or based on what I want. If I choose one check, it will compare the genotypes to that check. But if I select more check, it will compare the average of the performance of the check. I compare it with the other genotype. So as a breeders, I might be interested to select based on higher value, low value, and then values between range. So for some trait, we might be interested to have higher values. For instance, the yield. We may be interested to select the genotype that have higher yield, or where the yield in this case of the genotype are beyond the average of these two checks. For some other traits, we may be interested to selecting based on lower value. For instance, the days to flowering, we want to shorten the cycle. If you can have a good varieties that is performing well, and where the cycle is less compared to the same variety that are producing similarly, but with higher longer cycle, we would prefer going to the one that is producing in shorter cycle for obvious reason. So then for this kind of traits, so for low values, we can select the days to flowering. For some other traits, it may be difficult to say that we want higher or lower. In that case, maybe values between range, like the plant high, can make it. For instance, we can select plant high and put a range that, okay, we don't want higher, we don't want low, but we want values between range. So any plant that is between this range can make it. So this, we are setting the scene, and after that, now we, as I was saying, we might be interesting also to bring the Shukla stability that will come alongside the performance of the line and so we can also have another decision point. So after that, selecting what I want, I remain that here we are comparing using the combined analysis, comparing this the performance of my genotype with the average of these 3 checks, and I have chosen the traits of interest. So here I can select more. Here in this example I have only 3 traits, but I could have 10 traits, and for each I can select more traits for the higher value, more traits for the lower. I can do multiple selection. So after that, I will run this selection, and I will have the output. So here I have different tables. So the first table is like a remind that the genotype above the performance of the check are highlighted in green or red otherwise. So what does it mean here? I just remind that for the check 1, check 2, I remind the average we have in the database. So we have the yield for the check 1, the yield for the check 2, the yield for the check 3, and then of course the average here. So this is what I have chosen here as higher value. So for genotype, so for the lower values here, I also selected the days to flowering, and I can see that here for the check 1 we couldn't have data, so it was missing. For the check 2 we have the days to flowering, for the check 3, and of course the average will be calculated based on the check 2 and check 3. And for the plant high values will be within range. So we have remind here the values that are chosen. So stability here in this table is the Shukla stability, as I mentioned. So now here we have the table of the output where we have my data. Okay, so compare everything, but we should start checking from the genotype number 11. So here what we have here is coming to the flowering. We indicated to ViTSel that we want all genotype that have lower values than the check when we select the days to flowering. Here the mean of the checks is 89.44, and here for this first one we have 86.72, so that is below this average, so then it is in green. For the plant high, similarly, we want values between 87 and 102, and we have seen here that this value is in the trend, so it is in green. For the yield, it is in red, because for the yield we want values that are above 6,150. So the yield for this genotype is less than 6,150, so it is red. So what does it mean? It means that just with a quick visual assessment, we can see based on, of course, all the traits, they don't have the same weight, but based on our interest, we can start looking, for instance, the yield, and see that, okay, I'm interested with all yield green, and after that, maybe we can have, for instance, this one, where the yield is in the good shape, the plant head, and then the flowering. So the main idea is to check quickly where we have green, all green in one line, or it doesn't matter if you have one green here, maybe one green here, and the other one we can still select it. And of course, in addition, we can have also this stability, this variance, and we have the rank, so that we can also see for some good varieties that so this one is good in average, but we have seen that it's not too stable. So that means this genotype might be interesting for some environment globally. There is doing very well in some environment, but not maybe in other environment. It can be selected overall, but also can be considered for local adaptation. For some others, like this one is the number one, is good globally. The plant height is fine. The days to flowering is not based on what we want, but it's not very far, 89.44, and here we have 89.62. So the breeder might decide it is still to consider it for further development. So, and this table also can be downloaded to Excel, and it come here with the name, and it will come to Excel with all the colors that are here rendering in the web browser. Why we want to send it to Excel? Because we know that definitely also Excel can be used to do further manipulation that is more easy compared when doing it in ViTSel. For instance, the filtering, the sorting, and all these things that can be done. So I'm just opening my Excel. My Excel sheet where we can see the color are coming through into Excel. So coming back to ViTSel, so this is the first analysis where we compare the genotype to the checks, and based of our criteria, all the varieties that match that criteria are in green, and the ones that are not matching are in red. And the idea is quickly we can pick those that are matching everywhere, considering the multi-trait criteria. So the same idea when comparing varieties to standards, as I mentioned. So we can still do it overall or location by location. Here is the same principle. We select the yield as higher value. We select the flowering as low value, and then we select here the 8 as using range. So the difference here is compared to what we have seen before is for each trait, let's say the flowering, we were selecting low value, it default to the average of all the genotypes. So this 90.54 is the average of all the genotype for days to flowering. We can use it as a default, as I'm mentioning that the average can be seen as a potential of the TP if you consider that we have the TP in our data, or at least using the environment I have. So this is the average of the environment I have. I can also ask for the stability. So I remind that maybe the stability will be most useful for yield, but we can also use it for other traits. So if I run, I will have the same idea that the yield here is the default value is the average calculated from the data. You can choose other value if you wish, but for first run, I think we can see that the default for the yield is this value, the default for the trait is this value, and then default for the 8. So I select the whole range. But if I wish for any reason, I don't want to compare with the average, but maybe I have some standards, either because the National Variety Release Committee has decided that, okay, we want varieties that are beyond 5 tons, for instance, if you consider rice or whatever the crop we want, we can also change and then push the threshold here, move it from the default value to another value. We can also change here the yield from what it was to another value, and change also the height. And as it is interactive, if you run again, we'll have other values. And here we can see that the default value is what we had before. Previously, the yield was 6.49. Now we have chosen 633.9. So this is the chosen value, and the output is rendered based on the chosen value. So, and then we can do it whatever we want. So in using one interface, we can use different scenarios. Okay, at this time I will move the yield, the standard. I will move this one, and I will run again, and I have different values, and see if I am okay with what I have. I can play around and get different selection. The criteria will match anytime I choose, so it runs immediately to here, and after we are done, we can download and that keep this value. So the difference between the two is the first one, as I mentioned, was comparing the genotypes against locally adapted varieties, mainly the checks, and this one is comparing the performance of the genotype with standards. The breeder set him or herself. The next two are the index selection. The first one is the rank, simple rank selection, where we can also select globally or by location, it doesn't matter. And we can select the trait of interest. So I guess that, for instance, for this case, you might be interested in selecting all the traits. The interface here is straightforward. You just select the trait you want and we click on run. So what is done is the breeder selected the traits of interest, and for each, for instance, the flowering, the best genotype is rank number 1, and the second best is rank number 2, and then you have the rank. For the plant height, we do similarly. We have the three ranks of the traits here. The best genotype is rank number 1. The second best is rank number 2, and also on. So then we have the rank of the 3 traits, and the sum of the rank is the rank summation index, and lower is the rank, and better is, if you can say it like that, is the variety. So then we sort it. So here is straightforward, and then we can download this one and see what is the best genotype based on rank. But by doing this, we are assigning the same weight. We consider that all my traits are playing the same role, which might not be the case. And then because of that, we also have the base index, where also the same, we selected the traits of interest. But here, by default, as I mentioned, each of the weight is number 1, so that the traits, they have the same weight. I can run it here, and then to see what is the best genotype based on this ranking, and what is done for the base index is as the traits, they come with different units. So we standardized all the traits, and then we weight them. So the weight that is provided by the breeders here is used alongside the standard values to calculate the base index. So, and then of course, each weight is assigned by the breeders who know better what he wants to get according to the importance of the traits. You can just provide, for instance, more weight to yield in this case, and the plant height, we can reduce the weight, and then there's the flowering also, we can reduce the weight. You can think this can be a scenario, but this is based on what the breeders want to have. And if you run, we may have a new ranking. You can even, for instance, provide a negative weight like this one, for instance, for the flowering, and keep the plant height as low as possible, and then increase the weight of the yield. So whatever the trait we provide, so it will automatically take that weight we input in, and then standardize the performance of the genotype, and take the weight to the standard values, and estimate the base index, which is the sum of it's a linear combination of the weight and then the standard values, and then the varieties are ranked based on this weight. So this also, we can download it and then use it for further manipulation. So this is all what I have in this demo. So we are ready to take any question and clarification you may have. Thank you for listening.
Thank you very much to Ibnu for the excellent demonstration, and also to Juan for introducing him. I think that we had 2 questions so far that have come up in chat. One is from Lucas Mueller about whether there is a plan to connect this tool to BRAPI, the breeding API. If you have any comments on that.
Yeah, this is a good question. When we were developing, as Juan said, CIMMYT, they have long experience to develop tools that can be used with breeders using Java and other tools. So when we started here, this ViTSel is 100% R Shiny. So we develop it as a standalone tool to be run locally using our web browser. But definitely, as Juan also mentioned, the idea is we want to have like a small apps that is portable, that can be available quickly. But at the end of the day, the idea is to vest this tool to any other broader initiative. It can be, for instance, I think ultimately it should be EBS. But the main idea also is to, at this time, is not BRAPI compatible, but the idea would be in the future, of course, to make it BRAPI, if I can say it like that. So it can be used to any, if there is interest, to any tool that can be of interest of the breeders. So yes, it can be used for integrated to EBS or any other app that can work. And in that case, of course, make it BRAPI compatible would be the best way for that. But at this time, no, we haven't started that one. Maybe we should collaborate more with other colleagues for that.
Thank you very much. The next question that came in is from Yao. How does the program detect sorting order for ranking index?
How the program detects sorting?
So in the previous page before this one, where you looked at the ranks of each of the trait and generated sort of an overall rank from it. Is it treating each of the phenotypes? Is it sorting? So for instance, the higher the value, the better, or the lower the value, the better? Because for instance, the days to flowering, lower the value, the better. And for yield, higher the value, the better. So how is it dealing with the sort order?
Yeah, that is a good question. In fact, for the you have seen that for the checks and the specified values, we put where the user should input which trait to be considered as higher when we want higher or lower value. But for the rank index, we are not yet at the level, but that is something to come. So I mean, after selecting, we should let know at this time. Okay, at this time, higher the value, better is the genotype. So maybe for the rank summation index, at this time we should select at once all traits that we want higher value. For instance, maybe height or yield, or all values, all traits that we want lower value. Definitely, the next step for the index selection is to provide possibility like in the other in the other interface where we can differentiate the higher and the lower values. Yeah, we are not yet at the level in the selection index, but that will come shortly in the next version.
Thank you. The next question that came in was from Sarah Hearn. She'd like to know, when you download after applying weights, is the metadata of the weights that you applied also exported?
Sorry, can you come again? If you download the metadata of the app?
So I think it's if you apply weights, then after you've applied those particular weights, when you do the download, does it also include the information about what those weights were? Or Sarah, if you'd like to rephrase your question.
No, that's right, Kate. So when you export the data after applying whatever weights you've somehow decided upon, are those weights exported in addition to the data? So if I look 3 months after I've done this, can I see what weights I applied?
For the base, for the rank summation index, the weight, for the base index, the weight is not downloaded. So yeah, this is a good point that we should also provide the weight. We should add in the metadata in the table above, reminding to the breeders that the weight he has chosen. So yes, this is a good question. It's not downloaded, but we can easily add it.
Thank you.
Thanks, Ibnu. The next question is from Mary, and this is addressed to Juan. She'd like to know if the software for the line by tester design and the ViTSel, if they can be used for all kinds of designs, trial designs.
Yeah, I will answer, and then Juan, please, if you can complete my answer. So the answer is for the ViTSel, yes, because what we use as input data is the performance, the table of the performance of the line. So that means whatever the analysis you did using your own design, you end it with table of G by E, table of the genotype by environment, and that include already your design in the analysis, and that table of G by E, table of means is submitted to ViTSel for analysis. So for ViTSel, so the answer is yes, but maybe Juan want to develop more on that. Juan, please.
No, yes, what you said is completely right. You can use ViTSel with any kind of analysis. The line-based tester design, the visualization tool for line-based tester has other capabilities. As Imnu said, you can select by specific combinability or also for general combinability. And then it's a different kind of tool. The line-based test is more specific for this kind of analysis, or also the ALL analysis. You can use the line-based tester visualization tool.
All right, thanks, Juan.
Thank you.
So the next question that came in from Milka was whether a user can save their selection criteria in the tool for future reference or reuse.
Not yet, but this is a good point. We can see how to. So if I try to look at it, the idea is if you can automatize more if you can reproduce the analytics. So that means when a user come and then play with this tool and then happy with some weight or whatever he wants as input, and save this as set of instructions, and if this can be used later on. If you just input the data and click on one button to reproduce all that was done previously. Yeah, we haven't do that, but yeah, this is a good point we can investigate in future version.
Thank you. The next question comes from Noelle, who starts by complimenting you on a nice presentation, and she'd like to know how many traits can be entered into the tool for the analysis, and whether there's an upper bound on either the number of traits or the number of genotypes that you can use.
So technically, is unlimited number of traits, unlimited number of genotypes. As far as this can be handled by Excel and using the classical import tool from Excel to R, because we are just storing the data in Excel, and that's why it may be interesting also to consider as a data format, as I mentioned in the beginning. So we'll be exploring importing CSV file or even some database, link it to some database where we can have more power. So at this time is the number of rows of Excel and the number of columns of Excel that can be used, and using just like the tidyverse tools to importing data from Excel to R. As far as we can handle the data in Excel, so we can import it because there is R is playing in the background. So yes, technically this unlimited, but of course unlimited in the sense of Excel and number of rows and columns. So you can use more than 10,000 rows and columns.
Thank you. So the next topic in the chat is a comment from Gary Atlin, who notes that there are no measures of variability. We need to know repeatability before we can assign weights. Do you have any comment on that?
Yeah, that is particularly true. So that's why I mentioned in the beginning, and this is what we discussed with Juan and the teams, so that we assume that the mixed model analysis is done by the breeders using the state-of-the-art techniques, including pedigree information if they have, including the spatial analysis if they have, and analyzing the data side by side and look at the heritability for each trait, and looking, for instance, all the site where you have null variants, and discarding or whatever, considering whatever they want to push for. Now, after all this done, so ViTSel will start from there, assuming that you already discard or already consider all your data. If you are happy with the repeatability, and if you have that, now you can submit your data to ViTSel. So, true.
Can I make a quick comment on that? I don't think you can assume that is how that data quality and that quality of analysis will be undertaken. I think a lot of people will put raw means into this software. You're going to have to be very careful about how you advise people how to use it.
True. So the idea was so we have this what I call this data analytics workflow. So we have from the experimental design to the decision support tool. So ViTSel is at the point of the decision support tool where the design was already set up by the breeders team, and then maybe their biometrics teams advising them to using state-of-the-art design, and the data analyzing using state-of-the-art techniques. So after from that, now ViTSel come in. But of course, ViTSel should be linked to what happens before. And the idea was ViTSel will not analyze the raw data by itself. But I completely agree that maybe in terms of communication, we should more ask the people that even if you are using ViTSel, don't just run your analysis wrongly and use ViTSel expecting that ViTSel will do the selection for you. But of course, completely agree that there is a lot of things that start even from the experimental design. You need to choose if you are doing spot testing or whatever the new techniques we have. You need to collect your pedigree information, as I mentioned. You need to take the rows and the columns to increase your estimation of your BLUPS, and all this good advice, of course, should be there before. And then after now you get that one, now you can submit it to ViTSel. Will take over from the needs. Yeah, in that sense, yes.
I want to add also that you can calculate selection index before and include a selection index like a trait. And then you don't need to, you can do the right calculus, as Gary said, including genotypic and phenotypic variants, the right weights, etc., and just include in the input table the selection index like different columns. And then you can use this just for visualization. That is the objective of this tool.
Right.
Thank you. So there were some questions that were coming up in chat about whether this software is free and how it's available. And I thank everyone, including Juan, who responded with the link to download this particular tool, as well as I think the line by tester that was mentioned. So hopefully if everyone consults the chat, if you're interested in getting this tool, you can find the link to that there now. But continuing on with the questions, and this may be sort of relevant to what was just discussed. Suda from CIMMYT was asking, is there a possibility to plug in LSD also apart from the absolute values while comparing genotypes?
Should be the input data again is the G/E table that we get from previous analytics. So so there are two scenarios from this one, and this need to be discussed by the developer teams. We can connect it and then use later we can connect it to the raw data. So then we can say that, okay, let's also provide the possibility when some people they have the raw data. So they input the raw data, and from the raw data we can estimate the BLUPS, the heritability, the LSD, whatever the statistics we want to get. And that can come automatically. And from there, we go for the visualization and then the line selection. This can be a way. Another way also is what we have decided to go quick is that we assume that, or we see that, okay, the users use tools. It can be R, it can be SAS, it can be ASRML, whatever the tools they can use, or the breeding view from the BMS, or whatever the tool people can use to get their statistics, like the BLUPS and all the statistics. And from there, they bring it in to ViTSel, and we can play with it. So there are the two options. At this time, the option we have chosen was that one. You use tools that can estimate some statistics and then some BLUPS, and then you input this table of means to ViTSel to do the visualization. But we can think also maybe adding more, but that will take more time, and that will also provide probably the flexibility or to have the continuum of the analysis. But what we're thinking is the tools for that exist already. For instance, the EMIT for that CIMMYT and Juan and his team, they develop Meta-R that is using similar techniques where you input raw data and you have a Java interface and then R in the background that can produce several statistics is also there. So now the question we'll be asking ourselves in the future is, should we connect like MetaR and ViTSel to have a continuum, or should we maintain it separately? So that need to be discussed by the developer team. So to have it one, but in any case, it should be possible to bring in whatever the statistics you want, like LSD heritability, to provide more insight.
Thank you. And I thank all the participants. We have lots of excellent questions coming in, so I hope maybe we can go a minute or two past the time to try to answer some of these. So the next one is a comment from Dutmala. Why have you put only Shukla stability index to measure stability? I don't think that the same index is applicable to multiple crops. It would be better if you can expand choices here. So do you have any comment on that?
I don't get it well, sorry. Multiple crops?
Deepmala, would you like to follow up?
I just saw, I think, breeders and I mean, from all the working all the crops. So I just wanted to ask, why is there only one index there to measure stability, although there are different indexes available? So if and from different indexes you can get different ranks and different parameters. So just to know why only this was selected and there are no more choices to play with.
Yeah, that's true. At this time, as we input it only the G/A table, we don't have the raw data, then we cannot go to using like the Smith index. So this is what we have so far. Then this is related also to the question I answered previously. If we decided to go to connect it with the raw data, we can input in, and then we can estimate the variance, the genotypic variance, and then going further to provide more index selection. So that can be a possibility, of course. We know that, for instance, the rank summation index might not be terribly useful for breeders, because nobody is assigning the same weight to all traits. We know already. But that will depend now on how we wanted a simple tool, quick, and then we start from the G/A table to have something quick. But of course, now there is the cost to pay is we don't have raw data, so we cannot play more, having more possibilities. So this is something we need to think and to discuss with colleague from CIMMYT, how we are going to, or we can have it calculated somewhere else and then bring it here and play with the visualization to have it displayed.
Right. Okay, thank you.
Thank you.
Thank you. Just one quick follow-up question on that from Anil was in the particular, I guess, demo that you gave, which trait was the Shukla's index calculated for?
Which trait? Sorry.
Yes, it says Shukla's index was calculated for which trait in the current example?
Okay.
Was the question.
Yeah, it was just all the traits I use as an example, days to flowering, plant height, and yield. But there was a good question that coming from I think from Yao, saying that okay, as we did when we were comparing the genotypes to the checks, we differentiate the role played by the traits. There are some we want high value, some we want low value. So for the rank summation index also we should do similarly, and it's not yet there. This is what we are going to bring in. So in the rank summation index and the base, we should also specify to ViTSel which one we want higher value or lower value, so that then the index rank summation index particularly can take into consideration that point. So at this example, what we have chosen was the days to flowering, the plant height, and then the yield, just in the demo.
This is Anil. So here at a time for the Shukla's index, at a time you can calculate for one trait. Here you don't have any option to given to calculate the Shukla's index. So overall you calculated, how you calculated that thing. So why? Because when I gone through the Shukla's index, it is giving the some variances in that there. So I think it must be a one particular trait. Can you clarify that thing?
What particular? I sorry, I don't get it well. One particular trait for the index, or
no, not for index. Yeah, Shukla's index at a time we can calculate for one trait. So, is there any option to give the trait name to choose the trait name. For the trait, it calculate the Shukla's index or what?
Okay, sorry. Yeah, I was very fast maybe in that case. So for instance, in this check, we have different part. This is what we call the multi-trait analysis. So we have different analysis that is in the same table. So from these 3 columns, what we have here is the performance of the flowering, days to flowering, the plant age, and then the yield. And in this stability and rank stability is calculated based on only one trait.
Understand. So just I'm asking that option. Why? Because I didn't see that thing. So okay. So if trait selection is there, then it's fine. Thank you.
Yeah. So okay, thank you.
Thank you. And I know we're over time, so maybe I know there's been some good discussion in the chat, which I think that we can save and share with the presenters. But maybe just one more quick practical question that came in is that sometimes trait names contain special characters, for example, a percent sign, or missing data sometimes is encoded as dots or maybe blank spaces. How does the tool handle these exceptions?
Yeah, of course, this is the classical advice we provide for naming the variables. Just like we are working with R and SAS and ASRML, we should put the name without space using the alphanumeric values from 0 to 9 and from A to Z, and of course using the classical tools we have. Even if it is there, we have a special character, it will render in any case using some fancy sign that will not be easy to see, that will not be lovely to see, but it will come. But of course, the idea is ViTSel is working with R, and the same advice applied to R or SAS or whatever the tools we use for analyzing data are the same here. So just use simple name without space and then without a special character. That will help to have the name easily displayed.
And for missing data values, can it accept multiple types?
Sorry, for
missing data values? For
the data values?
For missing.
You can use
missing. Okay, sorry. Maybe one. Yeah, for the missing. Okay, hold on, please. You want to say something?
No.
Okay. So for the missing values also is for the missing values is the same. Just leave it blank, like a classical R data handling. So we have a table of G by E with the column name of the column using alphanumeric. And then the missing values like empty cells in Excel, and that will bring in, like if you see this table here, you see that it comes into NA, not available, or will transform the empty cells to not available. So, but we should not put NA in the Excel file. So yeah, just leave it blank, the empty cells.
Thank you very much. And I don't want to take more time. I thank everyone for staying a little bit late. I think, as I said, that there's some great discussion in the chat, which can be shared with the presenters, and which I hope everyone has been able to read. And I thank very much again, Ibnu and Juan for demonstrating this tool to us today and answering so many great questions from the participants. So thank you very much for the engagement from everyone.